We're going to do a video that reviews PI and electrophoresis. Oops, wrong spot. Sorry about that. And here we go. We have this problem here. And before we start, electrophoresis is the method of choice for separating amino acids and proteins. And it takes advantage of charge. Yes, it also takes advantage of size, which we're going to ignore in our discussion. But charge is the most important thing for us. And what you have is a chamber, an electrophoresis chamber that has two electrodes, a negative electrode and a positive electrode. If you're having trouble with definitions of anode and cathode, it's really not the charge, it's what happens at the electrode. An anode has extra electrons. It will cause reduction. Sorry, a negative electrode has extra electrons. I start over. A negative electrode, just look at it, has a negative charge because it has an extra electron. Electrons cause reduction. Reduction happens at the cathode. This thing wants to take electrons from whatever is near it. That's an oxidation when you take electrons from something. The site of oxidation is called the anode. Do you know how I remember that 30 years after I learned it? Reduction, consonant, R. Cathode, consonant, C. Oxidation, vowel, O. Anode, vowel, A. Okay, it's nothing to do with charge, it's reduction and oxidation. Okay, if you want to memorize a trick, the name is the opposite of the charge. Cation, opposite of the charge of the electrode. Anion, opposite of the charge of the electrode. But that's not memorizing the definition, that's a trick. Okay? So, any species with a minus charge is going to move towards the anode. Any species with a positive charge is going to move towards the cathode. The more positive the charge, the more it moves towards the cathode. It's a linear thing. If it's a 2 plus, it'll move twice as far towards the cathode as something that's a 1 plus. Okay? Once again, we're ignoring size, which would change that discussion, but we're pretending size doesn't matter here. So before we start this, we need to put these in order of their PIs. We're going to do it verbally. I'm just going to write the numbers here. I'm going to go to the handout, look for tyrosine, and figure out the PI of tyrosine. Tyrosine, where are you? Once again, I know it's open somewhere here, but there he is. We need this rotated. Thought I had this set up already. Tyrosine. Hey, this is the PI molecule already. How do I know? Charge 0, plus 1, minus 1. I need to keep this H off. I need to be above 2.2. I need to keep this H on. I need to be below 9.1. Those are the two numbers. Do not worry about this number. If you're below this number, you're below this number, this thing stays as is. That's what I'm saying. So 9.1, 2.2 is, add those together, 11.3 over 2 to get the average, 5.7 with rounding. I'm going to write that down. 5.7. ASP, and you shall receive. Right here. This thing has a -1 charge. This is not the PI molecule. Which of these gets an H first? The one with the lower pKb, which is this one. 14 minus 4 is 10. 14 minus 2 is 12. Lower pKb. So I need to keep this H on by staying below 3.86. I need to keep this H off by staying above 2.1. Those are the only two numbers that matter. I need this H to be here and this H to stay off. All right? So 3.9 and 2.1 is 6, divided by 2 is 3 for asp. 3 for asp. Cis, same story. CYS. I need to be above this number. It's already a PI molecule. I need to stay like this is basically the question. How do I do that? Above 2.01 and below 10.25. The average will be below 8, so this will stay like this. So 10.3 plus 2.1 is 12.4 divided by 2 is 6.2. I did that right? I hope so. 6.2. This stays like that, 6.2. Tier cis, we're going to have to use our imaginations, not our imaginations, our brains. Tier is on the left. So this is no longer relevant. It's an amide. Ignore it. Tier is hooked up to cis. So this is no longer relevant because it's part of an amide. So what do you got if you hook those together, ignoring those two things? I got a minus, I got a plus, and a neutral. So it's the PI molecule already. Tier on the left, cis on the right. I need to keep it like it is. Tier on the left, cis on the right. I don't want to draw it. So you got to ask yourself, of the combination of acids, which H comes off first? Tier on the left means these two are relevant. This is not. Cis on the right means these two are relevant. So which of these four numbers is going to be the most acidic? The 2, the 8, the 9, or the 11? Well, the 2 is not relevant because it's already off. So I want it to stay as is. Which one of these is going to come off first? 9.1. 9.1 comes off first. I need to make sure it doesn't come off. I need to keep it. So you need to be below 9.1. And where's your next H coming on is the question. I got tier on the left, cis on the right. The next H is coming on. You know, I'm having trouble following my own logic. I'm going to draw the thing. Tier cis. Ready? Tier cis. H3N plus and cis. Pretty sure this is the PI molecule already. That's PI right there. Look, plus minus, right? I should have done this from the beginning. I'm sorry. So all the numbers I'm going to grab here. And remember, this was a 2.2. So that's not for that H. There's no H there. What do we got? We had a 10.0. And we had an 8.0. I just need the tier ammonium terminal, which is 9.1. Okay, I want it to look like this is the main thing. It's already the PI molecule, charge is 0. Which one of these H's comes off first? 9.1. This is where I was getting to, but without the visual, I was having trouble. Please move this window away from the share group. Wow. Why are you doing that to me, dude? It's not funny. All right. That one's going to come off first, but I don't want it to come off. How do you do that? Stay below 9.1. Which one's going to come on first? This one, I don't want an H on there. I don't want an H. I want it to stay like this. How do you make sure the H stays off? pH above 2.2. There's your numbers, everybody. 2.2 plus 9.1 over 2. 11.3 over 2 rounds to, this sounds familiar, 5.7. Okay. No, that's not. Is that right? 5.65? It's 5.7. Good. Arg. At least the other ones I don't have to draw anything. Arg is here. This is not the PI molecule. It's got a +1 charge. So the PI molecule has this off already. That's the first one that's coming off, not this one. So the PI molecule has this, and it needs to stay off. You need to be above it, above 9.0. I need to keep this one right here, below 12.5. So there's your numbers, 9.0, 12.5. That's 21.5 over 2 with rounding is 15.6. Wait, what was it again? 21.5 over 2, 15.6. No, that's 21.2. 15. I'm going to do it over here. 21.5 over 2. That's what I wanted to hear. 10.7 with rounding. Sometimes you need to see it. Lice. Similar story for lice. Lice. This is not the PI molecule. This one's coming off first, and it needs to stay off. I need it to be off first. So above 9, above 8.95, which is above 9. But stay below this so I can keep it. So we'll call that 9.0. 19.5 over 2 is 9.75 rounds to 9.8. Got it. 9.8. Gly. Finally, an easy one. Gly, there's just two numbers. G. 9.8, 2.4. Add them together, you get 12.2 divided by 2, 6.1. 6.1. So which of these is the most negative? Lowest PI. I don't know if I'm answering my question yet, but these are the things I can know right away. This is the most negative one right here. So the question that you got a 50% chance I'm going to ask about that one. And the most positive one would be this one. Now let's look at what this question's asking for. Moves closest towards the positive electrode. It better be the most negative one. That's how simple this question is. He talks for 20 minutes and says it's simple. Anyway, sorry. Yeah, this question's asking which one moves most towards the anode right here. And that would be the one that's the most negative. So we're looking for answer B. I am definitely not going to have this many answers in yours. I'm going to try to cut it down to 4. So that was too much work for 3 points. I agree with you. So I'll have 4 species there. How's that sound? And we'll come back